We're on page 19, and honestly, letter B, there is nothing new in that problem. So I want you right now to go and do letter B. Find your x-intercepts, plot them. Vertex is halfway between. Nothing new to show you in letter B. Please try that one quickly right now. And Samira, we're on page 19, doing letter B. Page 19, letter B. I'm hoping the x-intercepts are very easy. They should be. Hopefully you have negative 2, 0, negative 6, 0 for your x-intercepts. That shouldn't be a big deal. Fiona, do you have the x-coordinate of the vertex? Negative 4. Honestly, you can either just count to the middle, or you can do the average of negative 2 and negative 6. But either way, you're going to get negative 4. As for the y, I'm going to plug that in. Maybe negative 12 for the y-coordinate. Negative 4, negative 12. I know right away, because the a value is 3, it should open up. It should be a little narrower than normal, and I kind of feel like if I go and connect those, yep, it's going to open up, be a little narrower than normal. And I've got a problem. Any questions or issues here? Next one. We have a little bit of converting we need to do in letter C. I would like to graph the x-intercepts in the vertex, but I first need to convert this to factored form. I mentioned this at the end of class yesterday. How do we convert to factored form? Just say it. Factor. That's all we need to do. We are going to get y equals, well, who wants to tell me some factors? Hands. I want to factor that thing. Lauren?
It's negative 1.
What will the factors, tell me x's in there as well when you do that. Tell me what the factored version, this is wrong, but x plus 5, x minus 8. That's what I'm looking for.
X plus 4.
There we go. That's what I'm looking for. Now, it's just like everything else we were doing. The x-coordinate of the vertex is a little messy. That's okay. It's going to be a fraction. When you plug in, though, it will be easier. Trust me on this. It will be easier if you plug into the factored version rather than the original, because then we don't have to square things. Our common denominator will be a smaller number. Plug into the factored version to get your y-coordinate. Go find your x-coordinate and plug in to find the y. Let's see what we can do with this one. I hope you're getting -3/2 for your x-coordinate of the vertex. Add -4 and 1, divide by 2. Again, with the y, plug into that factored version. It will be easier. You will have a smaller denominator to work with. Getting -25/4 then for the y-coordinate. I plugged in -3/2 plus 4, -3/2 minus 1. Needed a common denominator. So I turned my 4 into an 8/2. Turned my -1 into -2/2. -3/2 plus 8/2 is 5/2. -3/2 minus 2/2 is -5/2. -25/4, which is -6.25 for graphing purposes, and should look like that. Anything there? What should you do first in letter D? GCF. Always look for a GCF first. There is one here. Take out a -2. X squared. Then what? -2x. Then what? Keep going. Factor it more. And then graph. This will be a non-fraction-y problem. Go do it. Tyler, do you have the factoring for x squared minus 2x minus 3?
X minus 3 and x plus 1.
Perfect. That's what it should get factored into. So hopefully you can find the x-coordinate, x-intercepts easily. Vertex is in the middle. Again, I still think it's easier to plug into the factored version for the y. Not negative. Positive 1 comma what? What are you getting for your y? I'm like an 8. Positive 1 comma, -2 times -2 is 4 times 2 is 8. 1 comma 8. I knew from the start, though, it should open down and it should be a little narrower than normal, and I think that'll do it. Opening down, little narrower than normal. So in the homework, you're first going to need to factor these things to get the x-intercepts, and then vertex in the middle. Anything here? I'm going to wait a moment because I see a couple of you still making some notes. Next thing, a little bit of converting. On page 21, first thing we want to do is we want to convert that factored form into standard form. I haven't given you like a process for doing this, but I think you know how to convert that to standard form. What do? Lionel? Yeah, you multiply things out, you're going to FOIL, and then when you're done, you're going to distribute your -2. Go and do that. Take a moment and convert. Our process is just FOIL and distribute. -2x. Y equals, we do need the y equals part. Y equals -2x squared plus 12x plus 14. Now the directions say convert it to vertex form by completing the square. Well, this was just on your quiz that you took a moment or two ago. See if you can go and complete the square to convert it to vertex form, and when you're done, we'll have all three forms, and we'll talk about what each form is telling us right away from that form. Each form has its own advantages to it. I really hope that after you've moved to the 14, you're factoring out the a value, because you can't complete the square otherwise. Sam, what am I going to add in the parentheses? 9. And same on the other side, plus 9? Yeah. Be careful. Not plus 18. Minus 18, because this 9 is really a -2 times 9. It's really a minus 18. So y minus 32 equals, Laura, did you get this side over here? Can you factor it for me? Perfect. X minus 3 squared over there. Then I'm going to do plus 32, y equals -2 times x minus 3 squared plus 32, which is hopefully similar to things you were just doing on the quiz, I hope. What's the vertex of this parabola? Yeah. 3, 32, because remember this is moving at right 3 and up 32. But if we're in vertex form, we don't have any work to do to find the vertex. We can just read it straight from the form. Vertex form gives us our vertex. What can we tell right away from standard form? What is the y-intercept, Michael? 0, 14, which doesn't take any work if we're in standard form. But what do we get right away from factored form? The x-intercepts. Braden, going back to the original, what are the x-intercepts?
-1.
Yeah, and give me coordinates.
Yeah,
Perfect. Each form gives us something right away. I can look at each form and know some piece of information about the parabola right away. We're going to talk a little bit more about this a little bit later, but there's something else we have to deal with first. Do you remember the word discriminant from like 2 weeks ago?
Yeah.
What did we use that for with quadratic equations? What was the point? So that's the formula for it, the b squared minus 4ac. But what was the point of it? What did that let us do? Yeah, so it told us information about what the answers would look like to quadratic equations without our actually having to solve those quadratic equations. Are there going to be two complex solutions or one rational solution or things like that? That was the whole point of the discriminants. Let us basically separate our quadratic equations into different categories based on the number and types of solutions. There is also a discriminant for parabolas that will tell us how many x-intercepts we have with our parabola. Are there two x-intercepts? Is there only one? Are there zero? The formula for the discriminant is the exact same thing that it was in the last chapter. Our discriminant is b squared minus 4ac. And here's the idea. You can always use the quadratic formula to find your x-intercepts. We can sometimes factor to make them go faster, but if we can't factor, we can use the quadratic formula. Let's say when you're using the quadratic formula to find the x-intercepts, you get a positive value underneath the root. Then when you find your x-intercepts, you're going to do the positive square root of that thing, the negative square root. You're going to get two different numbers. You're going to get two different x-intercepts, which means our graph might look like this, might look like that, but it's going to cross the x-axis in two places. Take the plus or minus square root of 65, you get two different real number answers. If your discriminant is 0, that means when you're using the quadratic formula, you're going to get plus or minus root 0. How many different answers does that give you? Plus or minus root 0? 1, because there's no difference between plus root 0 and minus root 0. We are going to have only one x-intercept. I feel like yesterday someone in here told me what one x-intercept would look like. Who can remind me what one x-intercept would look like? Brittany. Perfect. The vertex would be the x-intercept. The vertex would be right on the x-axis. Maybe a vertex like this. Maybe, not a vertex, a parabola like that, or maybe a parabola like that, just touching the x-axis, not crossing it. I could also have a negative discriminant. Square root of a negative number, which we know gives us complex numbers. Can I have complex number x-intercepts? Where would I plot like 1 plus I on the x-axis? It wouldn't be there. If I'm getting complex numbers, which I feel like might happen in the homework tonight when you go to find x-intercepts, there are no x-intercepts. There are none. Because those aren't giving us real numbers. We can only do our graphs when we have real numbers. Hands for this. What does no x-intercepts look like? Lionel. Yeah, could be something like this. Actually, mine was in 2 quadrants, but it's still okay. My vertex was above the x-axis and I was going up. I could also have the vertex below here going down. No x-intercepts. Again, we have a formula, b squared minus 4ac. We'll use that formula. We'll determine which case are we in, and then are there 2 x-intercepts, 1 or none. Turn the page. Try those 2 on the top. I don't think I have to show you one of these. You can plug into that formula and figure out how many x-intercepts. Top of page 22. Silas, do you have the discriminant for A? Couldn't hear. 9, yeah. 5 squared minus 4 times negative 4 times negative 1, that's 25. Okay, this is positive 16 times negative 1 is going to give us negative 16. Discriminant is 9. And Silas, what's that telling you? 2x intercepts, thank you. 2x intercepts. I like it. Leah, do you have B? What do you have for the discriminant? That sounds good. 5 squared minus 4 times 1 times 8. That's 25 minus 32. That is negative 7. So how many x-intercepts for that parabola? None. No x-intercepts. And that's everything we need to know about factored form. Any questions here? Last thing that I want to do today. There's a chart on the bottom of page 22, which is basically going to summarize everything we've talked about so far regarding our 3 different forms. So I want to fill this in with all the information that we know. And again, this is going to kind of summarize what we've done, which honestly is going to be like 75% of your test that we're going to do after Thanksgiving. The first form that we started with was our vertex form. And I'm just going to make a little note here. That's everything we went into detail with in section 4.1. What is vertex form? What does it look like? Y equals... Is that a hand? Alyssa? Yeah. Yeah. We'll do H first. Perfect. That was the quiz you took last week. Actually, the last person now has taken it, so I'll pass them back at the end of the period today. There's something that's really easy to find if you're in vertex form, Brittany. The vertex, what is it? Perfect. The advantages, it is easy to find the vertex. The vertex is just H, comma K. And how did we graph those? This was how we started the chapter with the colored pencils, where we graphed our parent function and then applied our transformation. So I'm going to say transform y equals x squared. Take it, move it, stretch it, flip it, move it again. Then we looked at standard form, which should still be pretty fresh in your minds because you just had a quiz on that today. Standard form 4.2. Kiara, remember the form for standard form? Perfect. Y equals ax squared plus bx plus c. Hands for this one. What is very easy to find if we're in vertex form? Sam? Y-intercept. What is the y-intercept? Give me coordinates, though. 0, comma c. Perfect. I can look at that formula right away and just know the y-intercept. Well, to graph, this is where we first find the vertex and then make a table of values. So I'm going to say find the vertex. What's your formula for the vertex? That I hope you used all over that quiz. Negative b over 2a. I'm just going to say find the vertex and make a table of values. Finally, we have what we just spent yesterday and today on. Factored form, which is what we took a look at in section 4.3. Y equals a times x minus p times x minus q. Really just y equals a times some factors is our factored form. What's easy? Lionel? X-intercepts, what are they? Perfect. Just set your factors equal to 0, p comma 0, and q comma 0. And to graph something like this, we're going to plot the x-intercepts. And we're going to say that the vertex is halfway in between. And all the details of that, well, that's what we took care of earlier. Vertex is halfway between. Kind of the summary of everything we've done so far. There will be a problem or two in the homework, like what we did on the top of page 21, where you took one form, converted it to another, because now we have all the forms. We can work with all those forms. And I think that's about it. We're done with our third form.